Hey everyone, today I'm going to show you how I built custom MCP server to let AI interact with my home lab. So if you remember in last video we connected AI to Netbox, that was read-only access to your network documentation. But when it comes to actually doing something useful on your infrastructure, like SSH into the router and running the show commands, most of the AI setup just can't help you because they don't have access to your actual devices. But building your own MCP server changes this. And the best part, we are building this just 50 lines of Python code. So let's dive in. Alright, if you want to follow along, all the code I'm using in this video is available in my GitHub repository. I'll put the link in the description box down below. If you scroll down the MCP section, you will see video 13, custom device MCP server. And here is architecture diagram what we are building. So we have the cloud code on the left side, that is our MCP host. In the middle, we have the custom MCP server built with FastMCP and Netmiko. And on the right side, we have our actual home lab devices. In my case, 3 Cisco routers in EvenG. So when you ask Claude something like show me the version on the R1, the MCP server uses Netmiko to SSH to the devices, run the command and return the output back to the Claude. Think of it like giving Claude SSH access to your devices, but through a controlled interface that you design. And that's exactly what we're going to build right now. So let's get started. I'm here in my Ubuntu terminal. Let me just do a quick ls to see what we have. So I already have my MCP server folder from the last video where we set up the Netbox MCP server. Let me go into that. Now I'm going to create a new directory for our custom MCP server. I'll call it as device-mcp. So the first thing we need is to initialize a Python project. We are using UV as a package manager. If you watched my last video, you already have this installed. UV is super fast, it is built in Rest, and it handles all our dependencies really nicely. So let me show you what that created. So we have a few files here. The main one we care about is a project.toml. This is where all our project configurations and dependencies are defined. It's similar to requirement.txt but much more structured. Now we need to add our dependencies. We need two things. FastMCP, which is a framework for building MCP server, and Netmiko, which is a Python library for SSHing to the network devices. So this is going to take a couple of minutes because UV is setting up virtual environment, installing all the dependencies. You can see it downloading FastMCP, Netmiko, and all their underlying dependencies. Things like Paramiko, PyDynamic, and others. Alright, that's done. Let's just verify everything is installed correctly. Good, we have got Netmiko version 4.6 and FastMCP version 2.14. Perfect. So if you're curious about what else it got installed, you can run uv pip show FastMCP. This will show you all the installed information, the version, the underlying dependencies that FastMCP relies on, but you don't really need to worry about all these things. UV handles for us. Now here is where FastMCP really shines. So we're going to write our Endure MCP server in about 50 lines of Python. This is absolutely fantastic. So let me open the VS Code and create a new file called device_mcp.py. First, let's add some comments at the top so we know what this file does. Now let's import what we need. FastMCP is our framework for building MCP servers. Connect handler from Netmiko is what we use to actually SSH into the devices. Next, we create our MCP server. This is super simple. That's it. We now have the MCP server called device commands. Now for this demo, I'm going to hard code the device credentials. In production, you would absolutely use environment variable or secret manager. But for learning purpose, let's keep it simple. Now here is the magic part. We define our tools using the MCP tool decorator. And these are the functions Claude will be able to call. So the MCP tool decorator tells FastMCP, hey, expose this function to AI. And the doxing is really important here. Claude reads this to understand what the tool does and what parameters it needs. Good doxing help AI to use your tools correctly. So inside the function, we use Netmiko connect handler to establish an SSH session. Pretty straightforward, right? Connect, run the command, disconnect, return the output. Let's add a couple of more convenience tools. So these are just wrappers around run_command for common operations and make it easier for Claude to know what is available. And finally, we need to run the server. So that's our Endure MCP server, about 50 lines of code. Let me save this. Now one thing that would really nice if you could refer the device by the name instead of the IP address. So instead of saying 192.168.1.1.1, we would say R1. Let me create a device inventory file. I'll call it device.yml. Now I need to update my Python code to load this inventory and add a tool to list available devices. Now Claude can ask what are the devices available and get a list back. much more natural. Let me test if our server actually runs. And here we go. You can see the FastMCP banner. It says starting the MCP server, device commands with the transport stdio. That means our server is running and ready to accept the connection. Let me hit the Ctrl C to stop it for now. Now let's connect this to Claude Code. Same process as before. We use Claude MCP add. And let's verify if it is registered. And there it is, device-commands with checkmark status connected. Perfect. Alright, that's a quick setup guide. Now let's run the Claude for interactive automation. First type list available devices. And you can see Claude says I will list available network devices for you. It calls our list underscore device tool. And there it is, our three routers, VIOS R1, R2, R3. Now let's try something more interesting. Show the iOS version on R1. Watch what happens here. Claude first figure it out. It needs to get the IP address for R1. It reads our device.yml file to get the IP. Then it calls our run underscore command tool with the device IP and the show version. And there the output, Cisco IO software, version information, uptime, directly from the router. That's really cool. Now here is where it gets more impressive. Let me ask something complex. Check the OSPF status between R1 and R2. This is really interesting. Let's watch Claude reasoning here. So first we check if OSPF neighbor exists on both routers, wherein show IP OSPF protocol on both devices and get the empty result, no OSPF neighbors. But Claude doesn't stop here. It says let me check if OSPF is configured and running on these devices. So it runs show IP protocol on both routers. The result confirms OSPF is not configured on either router. Then Claude goes even further. It checks the interface status to verify the network connectivity between two routers. Run our get underscore interface tool on both devices. And finally, it gives a conclusion. There is no OSPF neighbor between two routers because OSPF is not configured on either devices. The router do have IP connectivity through the gig0/1 interface, but no dynamic routing protocol is currently running, which is completely accurate. And the Claude even offered to help configure OSPF on these routers. This is absolutely fascinating. So that's a quick way of building custom MCP server with FastMCP and Netmiko. In the next video, we are taking this even further, integrating MCP with Ansible. Imagine telling your AI to run the backup playbook across all routers. That's what we are building next. As always, thank you so much for watching. I'm going to catch you in the next video. Take care.